So NatureMetrics, we're on a mission to make biodiversity measurable at scale. So we use high integrity data to build up pictures of what is happening with nature in different ecosystems. So we can tell you the health of the ocean. We can look at rivers, we can look at soil, forests, woodlands at the individual species level. So it's using forensic science and DNA to identify any living creatures that are present in an environment. So this means over time you're able to see if oceans and rivers are improving or declining. We can see what species have been lost in different locations, and we do it in a way that is accurate, it's verifiable. Fundamentally, we want to see more finance going into nature-based solutions. We want to understand the impact that organizations are having in terms of the activities that they're conducting on the ground. Data is really powerful for two reasons when we think about the ocean. The first is we're able to actually quantify change. And that is very, very difficult with biodiversity, even using traditional methods. So when we're putting in place restoration measures, how do we know that they're working, and how are we able to tie back cause and effect? So we need the data to help us do that. The second piece, though, and particularly the piece that we're working on in terms of A, standardizing the metrics, and B, making them really, really easy to understand, is we need to bring together multiple stakeholders, and we need data to provide the trust on which they can have the conversation. So, to meet 30 by 30 and to create more marine protected areas, we need more financing. You don't need to have a PhD in ecology to be able to understand whether biodiversity is improving in a location. So if we can turn that data into something that is accessible for everyone, then we're all working from the same data points, we're all seeing the same change, so the conversations become much more aligned. So when we're thinking about next week, we really want to provide the foundation upon which those commitments can be made. We've worked with large clients across multiple sectors. So we've done work in the Amazon with WWF, right the way through to EDF Energy, so really helping them understand the impact that their wind farms are having on coastlines and the biodiversity in those locations. Typically what we will do with companies is start with the baseline. So before they start operation, before infrastructure work starts, for example, we will do a full survey of the area to understand what biodiversity is present. Once we have that baseline, typically we will sample every 6 months to a year while the work is ongoing, and we will be able to tell you whether species have improved, declined. Typically, we will see a pretty big impact immediately, but in the example of wind farms, sometimes we will see biodiversity recover after 4 or 5 years, and this is because of the infrastructure becoming safe haven for fish and other creatures to really kind of recover. So that's one example. And then another one is any restoration projects. So where we're trying to channel more capital into marine protected areas. We've done, again, baseline studies. We did a brilliant project off the coast of the Philippines, where our data was used as part of securing funding to create a marine protected area. And over time, we were able to show that the species richness inside the marine protected area was significantly higher than outside the marine protected area. And on top of that, looking at mangrove restoration further down the coastline, we found that actually the species within the mangrove conservation area were completely different to that in the coral reef further up the coast. So really breaking it down to what is happening with nature, but also connecting back the improvement in nature to the funding that went into creating the marine protected area. eDNA stands for environmental DNA, something that is left everywhere. So all living creatures leave it in their environment. We have eDNA floating around this room at the moment. And we will take water samples and soil samples and really zoom in on those tiny fragments of DNA that have been left behind by all of the living creatures in that space. The samples go back to our labs. So the first thing they do is they extract the DNA from the water filters or the soil samples that have been sent through. They then amplify the DNA and then they sequence it. So what comes out of the other side is a list of genetic sequences of every single organism that has been detected. We then match those sequences back to tell you exactly what creature they belong to. So, what comes out of the labs is initially millions of rows of data. We have a proprietary data pipeline that then synthesizes that. We match it back to species that we know and previous projects that we've worked on. And we will then tell you, in this location, these are the 50 to 100 species that have been identified. And we'll also classify them, so you know whether they are endangered, whether they're threatened, whether they're not least concern, and you can also understand if they're invasive as well. So any species that are present in an area where they shouldn't be, we're able to detect them early so that organizations are able to take mitigation measures much earlier. So we use satellite data for two things. One is to understand the habitat within which the samples have been taken. So what type of vegetation are we looking at, land cover, how connected is it, how has that changed over time as well. The other piece is actually starting to build out risk models and data models. So taking our eDNA data set and using data layers such as obviously habitat cover, temperature, precipitation, human impact, and starting to connect species distribution with those data layers, but we have continuous information coming in daily on. This gives us our species distribution models. So we're now exploring locations where we've not done any sampling, where we're able to extract information of the ecosystem, we're able to look across our reference database and actually start to form a picture of what we might expect to find on the ground. We do a lot of work with conservation and restoration projects, so that is very much where the business has evolved and where it has come from. And that is really showing and quantifying the positive uplift in biodiversity from the work that is happening. The second group are kind of your heavy impact industries, so mining, energy, infrastructure, anybody that is having an impact on the ground that might displace biodiversity. We work with them as part of their permitting, regulation, compliance, but also really being able to check whether post-operations, these sites have been restored and checking that at the individual species level. And then the last group are agriculture and agroforestry organizations. So anybody that wants to understand their soil health, how that might impact their crop yields and the resilience of their supply chains. We've seen a lot of regulation start to come through in the nature space. We have TNFD, for example, that really made companies think about nature for the first time. So that's really helped from a brand awareness perspective in terms of thinking about impacts and dependencies on nature across an organization's operation. What has been very effective and very interesting for us, and also very relevant to being here today, is thinking about how actually the finance sector can put nature on the agenda. So really moving up to where capital is being secured for project financing, some of the markers and the due diligence that is conducted as part of providing funding for those projects. How can our data and our metrics and our indicators be pulled into making those financial decisions? So, as soon as we get financial returns today that are linked to environmental impact, that is the piece that we see as truly game-changing for nature. So some of it is accountability, transparency of what organizations are doing, and actually being able to quantify that and link it back to financial returns. One of our investors, BNP Paribas, they've made commitments that they will be assessing their entire portfolio for their biodiversity footprint by 2025. So some of the work that we're doing with them is really understanding, and they have a huge range of investments and assets, helping them actually understand across those sectors what the impact on nature looks like. Because for them, it also links back to the risk involved with the investments that they have made as well. So that is a live conversation that we're exploring at the moment, and helps because they are actively investing within the nature and the environmental space as well. So they're quite familiar with the new technologies. The biodiversity crisis is urgent and it's happening now. Nature takes a long time to recover. We have the technologies that we need. We need to see them deployed at scale. And this is where the governments have to really step in. They have the power to not just bring the technologies together, but to actually unlock them across multiple locations, multiple ecosystems, multiple sites in a cohesive way, and actually being able to demonstrate what is possible. So I'd say now's the time. The oceans are not going to get any better without everybody coming together and actively and intentionally doing the work that needs to be done. I think the accountability piece is very, very important. climate change and biodiversity degradation is a generational problem, and fundamentally a problem that they're inheriting. So the more they can be driving that accountability, the more that they can be questioning behaviors and calling out behaviors, the more they're able to get people to listen as well. So I think they do have a power of their voice, even if they do not necessarily have the power of the capital yet. Really, really use the voice.